Okay, guys, as I promised, we will be talking about trig today. And what I'm going to do is I'm going to look at the things that you have to be able to do in the exam. Okay, so minimum things that you have to be able to do in the exam. So let's get started. Okay, the first thing, and even though it's a little bit later on in the curriculum, the first thing, and I think one of the most important things to know is your identities. Okay, your identities. You have to know your identities, not know where to find it on the formula sheet. Okay. So, let's quickly see who can give me at least one identity. Well done. So sine theta over cos theta. You're starting with easy ones. I like that. It's equal to tan theta. Okay, you have to know this. The reason why you know this is because all of you, when you see sine over theta, you will immediately know there's a tan in there. Or if you see tan, you will immediately think, oh, can't I replace it with sine? You immediately recognize it, all of you. Okay? Because it's an easy one and you know the identity. Give me another one. Sine squared theta plus cos squared theta equals to what? No. Positive 1. Okay. The moment, in other words, if I multiply everything with a negative, so negative sine squared theta minus cos squared theta is equal to negative 1. If everything is negative, then it's negative 1. Or a very common one is to say, well, cos squared theta is equal to 1 minus sine squared theta, or sine squared theta is equal to 1 minus cos squared theta. It's just the same thing. This thing, it's an equation. You just move the terms around in there or subtract it on the other sides, things like that. Okay, very important. You need to know these, but you guys do because they're simple. The ones you don't know is the, well, double angle ones. They're also fairly easy, but they're also identities, guys. You need to know these ones. Sine 2 theta is what? Oh. No, you don't know. Yes, but I promise you, I'm suggesting next year that they take that off the formula sheet, because the problem is, guys, you see it, you don't recognize it when it's from the reverse. So it is?
Isn't it going to be sine open bracket theta by theta?
No, it's 2 sine theta cos theta. So guys, what I'm saying is that when you see 2 sine theta cos theta, you don't think about going to the formula sheet, because you don't recognize that it's the double angle formula. Do you understand? You don't know 2 sine theta cos theta is sine 2 theta, and therefore you don't go look for it on the formula sheet. You stare at it and you don't know what to do. Can I replace it with tan? No. So you guys, please, you have to know this off by heart. Take this very seriously. I promise you. I promise you. It's like recognizing someone in a crowd. If you know, like, you will see Olivia from a distance in a crowd because you know her, you know what she looks like. So in the same sense, is in a question where you've got a complicated expression and you see 2 sine theta, or even if you just say see sine theta cos theta, you can think, oh, well, if I divide both sides with a 2, then sine theta cos theta should be equal to sine 2 theta over 2. You guys get that one? Does it make sense? Excellent. Okay, how about cos squared theta? Cos 2 theta. You guys know that one? Oh, I'm crushed to the heart, I'm telling you. This is it. Cos squared theta minus sine squared theta. So notice it's very similar. We call this the Pythagorean identity, because you prove it using Pythagoras. So it looks very similar to that one, but very important, it's the cos squared minus the sine squared. But remember that sine squared, we can replace sine squared with a 1 minus cos squared. So this can be, we can replace this with 1 minus cos squared theta. Then notice what this becomes. Now there is a minus, so this negative makes that -1, this negative makes that positive cos squared. So it's cos squared plus cos squared, so it's the same as 2 cos squared theta minus 1. Or I can replace the cos with a 1 minus sine squared theta. So notice now there's minus sine, so it's 1 minus 2 sine squared theta. Okay, again, I promise you it's not going to take you half an hour to study these off by heart. And the more you use them, you'll see you don't need your formula sheets. The only place where you need your, where I want to allow you guys to use your formula sheets is maybe for the, not even annuities. You guys should know those formulas off by heart. I can't think of a single good reason to use a formula sheet. All those formulas should really, because you should be able to recognize when you have to use the reverse. Okay, cool. The only one I really think might be helpful is the sine rule and cos rule. The sine rule is easy, but the cos rule is slightly complicated, but that's not necessarily, the cos rule is not necessarily one you will use in simplifying expressions. It's one you will know, oh, I need to use the cos rule, let me go look at what the cos rule is. Okay, so that's the way you should use formulas is, oh, I know I should use this formula, let me go and look what that formula is. While most of the times the formulas on the formula sheets is being used in reverse. Okay, now the difficult ones. Okay, the compound. These were the double angle formulas, the compound formulas. Let's start with cos one, because that's the one you should be able to prove as well. Cos A plus B is equal to, who knows? Sorry? Cos A cos B minus sine A sine B. This is how I remember it. I am convinced you guys didn't watch my videos. Okay, this is how I remember it. Sine is same sine, different ratios. Cos is different sine, same ratio. And for both of them, they will start with themselves. So for example, so sine, if it's A plus B, it would be a plus, same sign, different ratios. In other words, the one, it will start with sine, it will have a sine and a cos, a sine and a cos. See? Same sign, different ratios. Cos is just the opposite. Different sign, same ratios. So, and when you do sine A cos B, just since in the beginning it doesn't matter which one gets the A and which one gets the B, but in this one it's AB, and obviously I can't make this AB again, because then I've got sine AB cos AB sine A cos B sine A cos B. This one must be the different way around, sine B cos A. So cos, what will cos A minus B be, Bindile? Nice. Okay. Russo, sine A minus B. No. Minus. So sine is same sign, different ratio. minus. Excellent. Are you guys okay with that? Okay guys, so please make this your highest priorities to go and know these ratios off by heart. So let's just look at a few of the questions in the exam and see if we can't see a few places where we might have been able to use it. Okay. Just looking at it to see where we would have used our formulas. You can see this one, you don't necessarily immediately just see it. Okay, so let's just skip that one for now. Here we can see they ask us to determine sine A minus B. So what would this one be? Sine A cos B, plus or minus? Minus cos B sine A. So without your formula sheet, you've just saved yourself, what, 30 seconds finding it on that formula sheet and having to write it down correctly. Okay, here you can also not necessarily see it, but you'll actually recognize when you work a little bit with this one that you are going to use it. Okay, because if you take sine 54 degrees and cos 18, they don't necessarily come together. Well, cos 18, 3 times cos 18 does, but there's an easier way. If you use this one, if you change this one to a co-ratio, it becomes sine 54 is the same as cos of what? Minus 54. That gives you 36. So cos of 36, what relationship does 36 and 18 have?
36 is twice.
Exactly. Okay, so and again guys, because you guys use your calculator, you don't recognize that 36 is the double of 18. Okay, so avoid using your calculator as much as possible so that you can recognize this, especially when you prepare. In the exam is a different story because you can check yourself, but when you prepare you have time. So try and work it out in your mind and you'll see your mind is very sharp at recognizing things. There you can also see, once again, we use our double angle here. So what will we replace cos 2 theta with? Don't use your formula sheet. No?
Isn't it gonna be, can't we say 1 minus 2 sine squared theta?
That's the one we'll use. Because we've got another sine squared theta here, we'll rather use 1 minus 2 sine squared theta. And in the top, this will simplify, and we'll look at all of them just a little bit later on. I just want to show you once again how we're using our double angle identities. A lot of double angle identities and compound identities. Notice here that angle is 2x. In this question, I'm not going to look at it now, but it's 2x, which means that at some point I'm going to use my double angle identity to simplify it. At the moment you see a double angle, 2 times x, you're going to use double angle identity somewhere to simplify. In this case, it's going to be to show that BC is equal to 1. Okay. Okay, that's about it. Okay, I just quickly wanted to show you how important it is to know these and how regularly you will know. And I mean, this is in this exam. There's question 6 is trig, question 7 is trig. We used it in question 6. Almost every question, not the first one. There we used it, there we used it, there we used it. Question 7, as a matter of fact, you're going to use your compound angle identity here to break this open. Okay, so that you can have cos on its own. So use it in that question. Here you're going to use it. So literally one question in this whole paper, okay, that one you don't use it either. But one question in this whole paper does not use the compound or double angle identities.